Hey guys, this is Darshan Lokhande. I am a pre-final year BTech CSE student at IIIT Pune. Welcome to our channel Learn Competitive Programming with CodeChef. If you are interested in competitive programming and want to learn data structures and algorithms, this is the one-stop destination for you. We post weekly problem explanations and concept videos. So don't forget to subscribe to our channel by hitting that subscribe button and also the bell icon. The problem that we are going to solve today is Paparazzi Gennady. The problem appeared in March Long challenge and has a difficulty level of easy. The prerequisites for this problem are convex hull and geometry. But don't worry, if you are not aware of convex hull, you can still go through the video and understand the convex hull part just for the implementation. You might also need to revise some basic concepts of geometry before we implement the solution. Also, I'll be linking Nishchay Manwani's introduction to convex hull video in the description, so you can go over there and learn the prerequisites if needed. The problem statement goes as follows. Basically, we are given n vertical segments, that is a segment starting from coordinate I, 0 and ending at the coordinate I, hi. That is, it's a vertical segment and each of these segments will start from bottom, that is I, 0 coordinate, and end at some I, hi coordinate. So in this figure that I have drawn, you can see that there are a total of 7 segments, that is, let's say n is equals to 7. So I have drawn 7 segments and each of them start with the x-axis and go to some particular height. So this is basically given to us. This data is given to us, and now what we have to do is that there's a definition given that an segment I and a segment J, if let's say we consider two segments I and J, then the jth segment is visible from the ith segment if we connect their top points. So if I connect these top points using a line, then it is said that the jth segment is visible from the ith segment if no other vertical segment in between intersects this line. So you can see that here this segment number 3 and segment number 6 can be viewed from each other because segment number 4 and 5 do not intersect the green line. But if I try to see segment number 6 from segment number 1, then if I draw this line in between, then you can see over here that a vertical segment in between is intersecting it, so it is not visible. So segment number 6 and 1 are not visible from each other. So this is the basically definition that how a segment can be viewed from another segment. And finally, the task in our question is that we have to find the maximum possible value of modulus I minus j such that ith segment is visible from jth segment or vice versa. Okay, over all possible pairs. So there will be many pairs of segments that can be viewed from each other, right? So we have to find the maximum possible value of I minus j. That is the distance between those segments. Okay, horizontal distance between those segments. So this is the problem statement. Now let's see how to approach it. Also, in case you are wondering what is the answer for this sample case that I have drawn on the whiteboard, the answer is 3, because segment number 3 and segment number 6 are the farthest segments that can be viewed from each other. You can see that you can try all other possible pairs, but you will not get an answer greater than 3. That is why 3 is the answer, because difference of 3 and 6 uh, in modulo is nothing but the positive value is 3. To begin with our solution approach, the first thing that comes to our mind is the brute force solution. So the brute force solution would be pretty straightforward. That is, we would have to check all possible pairs I, j of segments such that j is visible from I. So what you will have to do is, first of all, iterate two nested loops over I and j, and then check if the ith segment and the jth segment can be viewed from each other. That is, you have to check all the segments in between and see that if they intersect this connecting line, that connects the top points of the ith and jth segment. So if you might have guessed till now, the complexity of this solution would be definitely order of n cube, right? Because n square complexity for running a loop over all I and j pairs, plus for each of these pairs, we have to check all the segments in between if they intersect this line, right? So n complexity for that. So n square into n O of n cube. So this complexity would not suffice for the full solve of the question, but you may get some partial points or you may solve a subtask using this complexity. So this is not a good complexity, and let's now see that how do we get a better solution for this problem. To get a better intuition of the final solution, let's say for a particular I, J is the maximum possible segment to the right that is visible from I. That is, uh, from I, we can clearly see the jth segment, and I am saying that J is the maximum possible segment to the right of I, such that J can be viewed from I. Okay, so if I am saying this, it means that all the segments that are in the between are of smaller height, right? That is, they are not intersecting with this blue line. And now you can see that if I pick any pair of segments in between, that is, let's say I have a segment over here P, or I have a segment over here, let's say Q, uh, the maximum distance between P and Q would never exceed I minus J, or I must say mod I minus J, right? So if you pick any pair, that is, let's say you pick the pair I minus P, or you pick the pair Q minus J, the distance between any two segments, the maximum possible distance is going to be this I minus J, because J is the farthest one from I to the right, okay? And if you pick any other segment in between, it will not exceed this distance. So this is one of the main points that leads us towards the solution. So how is this going to help us? So clearly one of the candidate solutions or the candidate answer for our problem is I minus j, right? That is this distance. But how do we calculate this over all the possible ranges? This is for a particular I. So to do that, what we can do is that we start with taking I is equals to 1. That is, this will be my the first segment then, right? If I take I is equals to 1, now I find the next statement, next segment, to the maximum segments towards the right which is visible from I. Let's say that is some segment P over here. Then I continue the process from P. I then find the farthest segment that is visible from P. Let's say it comes somewhere over here, and then finally I reach towards my end, that is, let's say N, and N is the farthest segment visible from this segment, let's say Q. So if we do this in a continuous fashion, the diagram that we will get in the end would look something like this, right? That is, we would get a polygon of some sort. You can see over here that we are getting a polygon, and it is bounding all the segments. That is, all the segments are present either on or inside the polygon. So now once we have this polygon, now you might get the clear intuition that the only possible answers that we have are these lengths A, B and C. That is the horizontal distance between these peaks, right? So we have to check which of these is the maximum. So this polygon that we get is actually called a convex hull, because it is the smallest convex polygon that is bounding all the points, the top points of the segments, right? So this is called a convex hull. You can read more about it on internet or see the video given in the description. But our problem is now basically resolved to, we start from the first segment, that is, I start from here, find the segment that is as far as possible to the right and is visible from 1. So I get that segment over here. Once I get that segment, I have one possible answer with me, that is A. Then my next mission is to find the segment which is as far as possible from this second segment. So that I find over here and so on. So I get another candidate answer, that is B. Then I get the candidate answer C, and the answer is going to be just max of A comma B comma C. So if I continue this process, I'll get towards my final answer. So now the task is that how do I determine that which of these segments is the farthest. So here you can clearly see that I have just drawn the diagram, and you can clearly see that it is the farthest segment which is also visible. But mathematically or using programming, how to find that from some ith segment which one is farther and visible. Let's say I have two segments, one is over here, one is over here. How do I decide which one of them is farther as well as visible from eye? So let's see the maths behind it. So now the only question remains is that how do I find a segment that is as far as possible from my ith segment? So I should be basically able to take a decision that if I fix this ith segment and I have two options with me, option number 1 and option number 2, then which one should I choose? Should I choose 2 or option number 1? That is, if 1 is visible from I but 2 is also visible from I and it is farther away. So which one should I choose? Definitely I should choose 2. But this we are able to say because we are seeing the diagram in front of us. Mathematically, we can represent them as vectors. That is, I draw two vectors from the top of I, this top of I, and one of them goes towards option 1, it is called the vector A, and the other one goes towards my option second, it is called my vector B. So how do I decide which vector is better? So if you see that the overall diagram that I am going to get of the polygon after final allotment of these vectors will be something like this, right? A convex polygon I will be getting, right? So first of all these vectors should be in clockwise manner. So they should be moving towards clockwise order, right? So that is one thing to notice. So according to that, you can definitely say that vector B is a better choice. Also, in another situation, it may arise. You can see over here in the right that another I, if I fix, again I have two options with me. I have option 1 and option 2. So which one do I choose? Vector A or B? So A is also option 1 is also visible, option 2 is also visible, but 2 is farther. And again, mathematically, I should choose B. And why? Because I should ideally follow the clockwise order of my polygon. So that is one thing, but to put it into precise words, if you see that the cross product of these vectors, so if I treat them as vectors because they are in a coordinate plane, xy plane, and if I treat them as vectors, so the cross product, that is A cross B, should be positive in the z direction. That is, if I do a cross product A cross B, as you can see over here, mathematical cross product, it will give me an answer in the z direction, right? That is something k cap. So that value should be positive. If that value is positive, then I will choose B over A. If my vector product of A cross B is giving me positive value, then I will choose B over A. Otherwise, I will not choose B. Okay, so that is the thing. So you can see over here, you can apply the right hand thumb rule to get the direction of the A cross B vector product, and you can see that in both the cases, if I do the vector product, the direction comes out to be positive z axis. So that is going to be our condition which we use to find which vector to choose, that is which segment to choose for the farther one. So let's say here I choose B over A. So I'll be now discarding my A vector, right? Because now B is the farthest, right? What happens if there is some another big segment present over here? Now this becomes my A vector and this becomes my B vector. And again, I check if the cross product A cross B is giving me a positive result. If yes, I'll again discard this old A, and now this is my new vector, which is a part of my final polygon, which is my convex polygon. So using this, Step by step, we'll just go on checking that whether to include the vector in my polygon or not. If yes, then I have to discard my previous segments, right? Because here you saw that when I chose segment 2 over 1, I discarded this one. Now when I chose option 3 over 2, I discarded this one as well. So we have to include some segments and then discard some segments. So we are going to see an implementation that involves this kind of thing plus the knowledge of cross product that we just saw. So this brings to the end of our solution. So now that we have understood this solution, let's understand more in the implementation part. So the C++ implementation of the code goes as follows. First, we take the input for number of test cases, and then for each test case, we take the input n, that is the number of segments, and for each input, I am creating a pair, that is point x comma y. So the point will be nothing but I comma whatever height the input is giving to me, right? So I am taking that input in this array of pairs, and now I have created a vector of pairs which is called poly because it denotes my current polygon that I have created till now, the convex polygon that I have created till now, okay, till the ith point. So initially I am inserting 2 points in that, that is my first point and my second point, that is segment 1 and segment 2. So to visualize it better, you can see that if this is my first segment and this is my second segment, I have not yet seen my other segment. So I'm just creating this polygon, that is I'm just inserting this vector which goes from this point to this point in my polygon. Okay. So further, I start my for loop from I is equals to 2, that is from my third segment. So this is I is equals to uh, let's say 0 because the indexing is 0 based, although the segments are 1 based. So this is I is equals to 0, this is index, okay. This is I is equals to 1, so I start with I is equals to 2, that is my actually third segment, okay. So the third segment would be here somewhere around here, okay, let's say it's something like this. So what I do is I check that this current segment is, let's say, called pt of I, that is this point is pt of I, okay, it is denoted by pt of I, and I check that whether this vector or this vector is better, that is I take the cross product and check this. So how do I do that? So I have some terminology for the same. So the terminology is as follows. I have the name x comma y for this point. For this point, I have the name x1 y1, and for this point, I have the name x2 y2. So if I have these points in the form of coordinates, I can easily find the cross product, as you can see over here in line number 26. So that gives me the cross product value. So I have to just check whether it's positive or negative, and based on that, I decide whether to drop this segment from my polygon. So if I drop this, then earlier there were like this side in the polygon, now this will get dropped off and I will have only this side in my polygon. So that is taken care over here. You can see that while sorry, it's taken care over here in line number 28 where it's written that while poly dot size greater than 1, that means I have at least 2 points in my polygon, and I'm checking for a better third point whether to drop or not this point, whether poly dot size is greater than 1 and the cross product is greater than equal to 0, I drop my last point in the polygon, and finally once this process is finished, I insert or push back this point in my polygon. So you can see that over here I'm pushing back, but before pushing back I have to see that what is my maximum separation between those 2 points. So this point and this point. So between these 2 points I check the separation in line number 30, that is answer is equals to max of current points x coordinate minus the poly dot back its x coordinate. So it's denoted by dot first, so I just subtract them and check that whatever is the maximum I maintain it in the variable answer, and finally I just print the variable answer to get my final value. So this was the implementation. I think it's pretty easy to implement. Uh, even more easier in C++ 17 because we have structured binding. So I don't have to worry. I just, store the pair in x1, y1, x and y, and I don't have to write dot first, dot second complex statements. So that's the other part. But implementation wise, I think it's easy if you know the cross product part. And also regarding the convex hull part, again, I will suggest that you can go to our YouTube channel, that is Learn Competitive Programming with CodeChef. There's a video available, Introduction to Convexel. There's a 1 hour class taken by Nishchay. You can get familiar with this concept. Okay, and there are many more such concept videos taken by our educators. They are present over here under this mini courses tab in practice and learn under CP tutorials. So you can see that there are many topics like backtracking, linked list, number theory. So you can learn these from here. There are links which redirect you to Unacademy where you can watch them for free. And if you want even more structured content with doubt solving, you can even opt for our plus subscription on Unacademy, and you can use my referral code Darshan 25 for instant 10% discount.